Alright, this is problem number 4 from the Winter 2015 final. It's about a double incline with two masses, M being the biggest, connected by a rope with tension T. The big mass M slides down, dragging along little m with it in a coefficient of friction of 0.25, and they ask you, if it slides that distance d of 2 meters, what is the speed of m at the bottom, and what is the tension of this rope? We have forces, we need sum of forces equals MA, so we need body diagram. I recognize that the tension is up the incline and the velocity is going down, so that gives me a friction force that's up and a tension that is also up. The normal force is perpendicular to the surface. Component of the weight perpendicular to the surface will be cosine, and along the surface will be sine. Now we do the same for the other mass, but we recognize that it's moving up now, so then the force of friction will be down the incline. This is important because although the tension is still up because of the rope, now the force of friction will be opposite to that tension and will be down in this case. And it will be in the same direction as the component of the weight, which is proportional to the sine of the angle. The normal force is perpendicular to the surface, and the weight component perpendicular to the surface is proportional to cosine. Alright, so we take these body diagrams and we put them into a sum of forces equation. It's very useful to draw our coordinates, y being perpendicular to the surface and x being down the surface. So let's start with y. We know that the acceleration in the y is 0 because the block is not going through the surface or jumping from the surface. This will tell us that the normal force has the same magnitude as the perpendicular component of the weight. So now let's do the x. We know that the big mass is accelerating down the incline, so its x component will be positive. And then we write down our forces. We write the weight along the incline, mg sine 53 from the body diagram. The tension was up, so it will be negative T. The force of friction was also up the incline, so it will be negative here. And it will have a magnitude of mu k times n. And we know that the normal force is mg cosine 53 degrees from the y equation. So we write it all down, and we will call it equation 1 because we will use it again. Alright, so then we do the same for little mass m. The easiest is on the y, but it tells us that the normal force is equal to mg cosine of 37 degrees. In the x, we have to be careful. This time, the block is accelerating up the incline and moving up the incline. So the acceleration will be negative if we define our coordinates as x being positive down the incline. And remember that the magnitude of this acceleration is the same for both bodies. So then, using the body diagram, we write down the forces in the x. The weight is down the incline, so it will be a positive. The tension is up the incline, so it will be negative. And this time, the force of friction is down, so we have a positive x component with these coordinates. And then we substitute the normal force and number our equation. So after this is all algebra. You get the two equations that you found using sum of forces. What you can do in two equations, two unknown, is isolate one of the variables. Let's do tension this time. And once you have the tension variable, then just substitute it into the other equation, equation number 1, so that now you can solve for the magnitude of the acceleration A. Alright, I'll let you solve for A by yourselves and tell you that if you solve for it and plug in the values, you'll get about 2.3 meters per second squared. And then if you have the acceleration and you have the initial velocity, then you can just find the final velocity by using kinematics, plug in all your numbers, and you will get that the final velocity will be about 3.1 meters per second. And to finish up the problem, once you have that acceleration, then you plug it in into the expression for the tension and get the final number of 207 newtons. Alright, so let's recap. It was a double incline with two different masses. First thing we recognize is this is a sum of forces problem, so I need body diagrams. So make sure you pick the tension in the right direction, the rope only pulls. Write down which way the velocity vector is so that you put the force of friction in the opposite direction, and also make sure you get the component of the weight along the incline. Then you do the same thing for 2, but remember this time it's moving up, so the force of friction is going to be down along with the weight, the tension in the other direction, and you still have your normal force and weight pretty much the standard way. So set up your sum of forces in the y. Know that the acceleration in y is 0. Do the same thing for the x, but make sure you pick the right sign for the acceleration. This time will be plus because it will be coming down. Then for body number 2, sum of forces in the y equals 0. Since it's now accelerating up the incline, this will have a negative component for MA. Number your equations. 2 equations, 2 unknowns. So for one of them, plug it into the other equation. Do your algebra, and then numerically find the values. If you have the acceleration and you know the initial velocity, you can use kinematics to find the final velocity. Plug acceleration into the other equation to get your tension, and then you're all done. All right, I hope this was useful.